This video is going to teach how we can solve quadratic equations using the square root property. First, I want to write down what types of quadratic equations can be solved. Usually it's for certain types. So this method is useful when you have a quadratic equation of the form something squared equals something, or something squared plus something equals something. Something like that. You need to have an equation that looks like this. One thing I should point out is that all your variables have to be here, or all variables here. Let me give you an example. An equation like this, perfect for the square root property. Or an equation like this, that's nice too. Or even like this. Notice how I said that all variables have to live in the first part, and so that's exactly what we have here. But something like this, this would not work because we have a variable in the first term and the second term. You can only have variables that live in the square if you want the method to work. This is not going to work. Okay, so let's go over how this rule works. Let's think about a very easy case. X squared equals 4. What x's will solve this equation? Well, let's notice something. Notice that if I move the 4 over, I get this. And then I can solve this using difference of squares. I can factor. And then I can set it equal to 0. Now, all I've done here is used factoring to solve the problem, but I want us to look at what the answers are. We got -2 and +2. Both these answers work in the original equation, but notice something. Those are both the square root of 4, aren't they? It was not random that we ended up with those. So what I could have done is just jump straight to the answer if I know what the answer is going to be. I got x equals plus or minus 2. But keep in mind that more generally what I really did is I went to x equals plus or minus the square root of 4, which then became 2, because the square root of 4 is 2. So this is in fact called the square root property. And I'm going to write this down. Okay, the square root property says if a squared equals b, then there's two cases. If b is positive, then a equals plus or minus root b. Now, what do I mean by b being positive? Well, what if I had, for example, x squared equals -1? I can't do the trick I just used because there's no square root of -1. At least not in beginning algebra. You'll learn that this can be done in intermediate algebra. You need complex numbers to solve it, but we're looking for real solutions here. So let me tell you what to do. If you have b less than 0, then there's no real solution. Okay? So that is the square root property. You know what to do now if b is positive or if b is negative. So what are the steps for solving a quadratic using the square root property? I'm going to label up here square root property just so we know what we're talking about. Okay? So step one, we need to first put it in the form where we can use it. Notice right here, this equation I said can be solved using the square root property. We just need to put it in the right form first. Okay? So step one is going to be to isolate the square. Once we've isolated the square, we're ready to use the square root property. So step two, use the square root property to solve for a. And step three, solve for the variable. So these are the three steps. This is actually quite an easy way to solve an equation if it's of the right form. Okay, so for all of these we're going to solve using the square root property. So problem 1. G squared equals 36. Well, since 36 is positive, then this means that G equals plus or minus the square root of 36, which means G equals plus or minus 6, and we're done. Notice I didn't have to do step 1 because step 1 is to isolate the square, and the square was already isolated. Okay, let's look at the second one. T squared minus 60 equals 0. Notice here my square is not isolated because I have a 60 on the same side. So I'm going to add 60 to move it over here. That leaves me with t squared equals 60. Now, since 60 is positive, I write t equals plus or minus the square root of 60. Don't forget though, I have to simplify always. So I have 4 and 15, which means t is equal to plus or minus 2 root 15. That is the easiest way to write my answer. Okay, let's get a little bit harder. Four r squared minus 25 equals 1. Doesn't look too much harder, but we do have that 4, so I want to teach you how to deal with that. First thing I do is isolate the square. I'm going to add 25 to both sides. I end up with 4r squared equals 26. Now we're not ready to use the square root property yet because I can divide by 4, so I can really isolate that square. I get r squared is equal to 26 over 4. Or if I reduce that, I get 13 over 2. Now, 13 over 2 is positive, which means that r is equal to plus or minus the square root of 13 halves. I need to simplify this though. Break up the radicals, and then I can rationalize by multiplying top and bottom by the square root of 2. I end up getting plus or minus root 26 over 2. And that's my answer. Okay, let's try another one. We're going to do about 8 examples or so. H squared plus 33 equals 9. So, proceed as usual. This one looks a bit easier. We're going to subtract 33 from both sides. We end up with h squared equals negative 24. Okay, negative 24. Now be careful. Negative 24 is less than 0. So what does that mean? That means no real solution. Right? Because if you forget this and you write this down, you know you're not allowed to have a negative under a radical, at least not when you're talking about the real numbers. So that wouldn't make any sense in this context. All right, let's go to the next one. P minus 11 squared equals 49. Now in this one, because 49 is positive, we can just go right ahead and use the square root property, and notice the square is already isolated here. So I get P minus 11 equals plus or minus root 49, which happens to be 7. Now I add 11 to both sides to actually finish solving for the P. So this is the first time I'm having to do this, okay? Which is the third step, solve for the variable afterwards. I get P equals 11 plus or minus 7. Always put the number in front of the plus or minus. Otherwise, if you didn't, it would look like this. And that looks weird, because it looks like the plus or minus is talking about everything, which it's not. What is 11 plus or minus 7? So 11 plus 7 is 18, and 11 minus 7 is equal to 4. So our answers are P equals 4 and P equals 18. Whenever you can break down your answers and write them, always do that in a list. Okay, let's keep going. How about this one? K minus 6 squared equals 5. Very similar to the one before. The square is already isolated, so since 5 is positive, then this means K minus 6 equals plus or minus root 5. From here, we just add 6 to both sides. We get K minus 6 equals, sorry, not K minus 6. The 6 is gone. We get K equals 6 plus or minus root 5. Now, unlike the example before, I cannot combine these because one's a radical, one isn't. So this is actually my answer. If I want to list them separately, I could. One's going to be 6 plus root 5, the other is 6 minus root 5. There's no simpler way to write it down. Okay, let's do another one. Number 7. 2f plus 5 squared equals 16. The square is already isolated here, so because 16 is positive, that means I can write 2f plus 5 equals plus or minus root 16. But that means, since plus or minus root 16 is the same as 4, we get 2f plus 5 equals plus or minus 4. We get two equations to solve. 2f plus 5 equals 4, and 2f plus 5 equals negative 4. From here we solve both equations. On the left one, subtract 5 from both, we get 2f equals negative 1, and divide both sides by 2, we get f equals negative 1/2. On this one, subtract 5 from both sides, I get 2f equals negative 9. Divide both sides by 2, we get f equals negative 9 over 2. So these are my two answers, f equals negative 1/2 and f equals negative 9/2. So yes, sometimes you do have to separate it into two equations. Let's look at the next one. This will be our last example. 4d minus 7 squared plus 12 equals 10. Step 1, remember, isolate the square. I'm going to subtract 12 from both sides. I get 4d minus 7 squared equals negative 2. Now be careful. We notice that the square is isolated here, but the right side is negative. What does this mean? No real solution. be very careful. It's really easy to forget about problems that go like this since they don't come up too often. That's it for the video and for the examples I wanted to show. Thanks for watching, and I hope you guys benefited.